There are more than 400 billion stars in our galaxy alone. Think about that number for a second. 400 billion, not million, billion. Our sun, the star that gives us every sunrise, every sunset, every season, every living thing we've ever known, is just one tiny point among hundreds of billions of others scattered across the Milky Way. And our galaxy, it's not special. Astronomers now estimate there are at least 2 trillion galaxies in the observable universe. 2 trillion enormous collections of stars, planets, dust, gas, and perhaps life. That's not poetry, that's measurement, that's data. So here's the question that refuses to go away. In all of that immensity, are we really alone? Are we truly the only intelligent life in the cosmos? The only beings capable of building cities, creating art, inventing mathematics, splitting atoms, launching spacecraft, and staring into the darkness, asking whether anyone else is doing the exact same thing somewhere out there? Or are we just one small chapter in a much larger cosmic story? I've spent most of my life trying to understand the laws of nature. Physics teaches you something important very quickly. The universe does not care about human assumptions. It does not reshape itself to fit our comfort. Nature only reveals itself through evidence, through observation, through relentless questioning. And yet, among all the scientific mysteries humanity has faced, this question feels different. Because it's not just scientific, it's personal. Every human being who has ever looked at the night sky has felt it. That strange mixture of wonder and loneliness. The realization that beyond Earth's atmosphere lies a universe so vast that the human mind struggles to contain it. When you truly sit with the scale of reality, something changes inside you. You begin to understand how small we are. Earth is a tiny planet orbiting an average star. That star sits in a quiet arm of an ordinary galaxy, and that galaxy drifts among trillions of others across a universe that has existed for nearly 13.8 billion years. Human civilization, everything we call history, occupies only a microscopic fraction of cosmic time. If the age of the universe were compressed into a single calendar year, modern humans would appear only in the final minutes of December 31st. That's how new we are. That's how brief our existence has been. And still, despite our smallness, something extraordinary happened here. Atoms formed molecules. Molecules formed cells. Cells learned to survive. Life evolved. Brains emerged. Consciousness appeared. And eventually, on one small world orbiting one ordinary star, the universe became aware of itself. That's what human intelligence really is. We are collections of stardust that learn how to ask questions. And perhaps the biggest question of all is this: did it happen anywhere else? Now, some people hear this question and immediately jump to conclusions. Either they insist aliens must exist because the universe is huge, or they dismiss the idea entirely because we haven't found proof yet. But science doesn't work that way. Science is not belief. Science is disciplined curiosity. The size of the universe alone does not prove alien civilizations exist. But it does force us to confront probability in a serious way. Because when you have trillions of galaxies and unimaginable numbers of stars and planets orbiting many of those stars, the possibility of life elsewhere stops sounding like fantasy and starts sounding like a legitimate scientific question. Not certainty, not fiction, a question. And questions are where discovery begins. What fascinates me most is that humanity has reached a moment in history where this is no longer purely philosophical. For thousands of years, people could only wonder. Ancient civilizations looked at the stars and imagined gods, spirits, or distant worlds, but they had no tools to investigate. We do, for the first time. In human history, we can actually search. We can detect planets orbiting distant stars. We can analyze alien atmospheres. We can scan the sky for unusual signals. We can send machines into deep space. Humanity has begun moving from speculation to investigation. And that changes everything. Because whether we eventually discover life elsewhere or discover that the universe is silent, the answer will reshape how humanity sees itself forever. Either we are one intelligence among many, or we are something unimaginably rare. And honestly, both possibilities are astonishing. People often say the universe is big, but that word is far too small for what we're actually talking about. So how do scientists actually approach a question as enormous as alien life? How do you even begin calculating the possibility of intelligent civilizations existing somewhere out there in the galaxy? Now we arrive at one of the strangest and most unsettling ideas in modern science. A question so simple that once you hear it, it becomes impossible to forget. In 1950, physicist Enrico Fermi was having lunch with colleagues at Los Alamos National Laboratory. They were casually discussing the possibility of extraterrestrial civilizations when Fermi suddenly asked a question that stopped the entire conversation. Where is everybody? That single sentence became one of the greatest mysteries in science. Today, we call it the Fermi paradox, and the reason it's called a paradox is because two ideas seem to contradict each other. On one hand, the universe appears overwhelmingly likely to contain life. There are trillions of galaxies, billions of stars, countless planets, and the chemical ingredients for life exist everywhere. Statistically, intelligent civilizations should exist. But on the other hand, we see absolutely nothing. No confirmed signals, no alien spacecraft, no undeniable evidence of advanced civilizations, just silence. And that silence becomes harder to explain the more you think about it. Imagine a civilization only a few thousand years more advanced than humanity. Not millions, just thousands. Human beings went from horse-drawn carts to space exploration in only a few centuries. We invented computers, satellites, artificial intelligence, nuclear energy, and interplanetary probes in an incredibly short period of time. Now imagine what a civilization could accomplish with 10,000 more years of scientific progress, or 100,000, or 1,000,000. A civilization that old might possess technologies beyond anything we can currently imagine. Even traveling far below the speed of light, such a civilization could gradually spread across the galaxy. The Milky Way is roughly 100,000 light years across. That sounds enormous, and it is, but on cosmic timescales, colonizing the galaxy could happen surprisingly quickly. Some scientific models suggest a sufficiently advanced civilization could spread throughout the Milky Way in only a few million years. And a few million years is nothing compared to the age of the galaxy itself, which is more than 13 billion years old. This is the heart of the paradox. If intelligent civilizations are common, and if even a small fraction survive long enough to expand into space, then the galaxy should already show signs of them. But it doesn't, at least not yet. And so scientists began searching for possible explanations. The first possibility is simple, though deeply lonely. Maybe intelligent life is extraordinarily rare. Perhaps the jump from chemistry to biology is so unlikely that it almost never happens. Earth may have experienced an event so improbable that it occurred only once in the observable universe. That idea is difficult to accept emotionally, but science cannot reject it simply because it feels uncomfortable. The universe does not owe us company. Another possibility is that simple life is common, but intelligent life is not. This idea becomes more interesting when you look at Earth's own history. For billions of years, life on Earth existed only as microscopic organisms. Single-celled bacteria dominated this planet far longer than humans ever have. Complex, intelligent life appeared very late. And even among intelligent species, technological civilization emerged only once that we know of. Dinosaurs ruled Earth for over 160 million years and never built radio telescopes. Evolution does not automatically produce civilizations. Intelligence may be a rare accident rather than a guaranteed outcome, but there's an even darker explanation, one that many scientists quietly worry about. Maybe advanced civilizations destroy themselves. This idea is sometimes connected to something called the Great Filter. The Great Filter refers to a barrier in evolution so difficult that very few civilizations ever survive beyond it. Perhaps civilizations develop powerful technologies faster than they develop wisdom. Nuclear war, environmental collapse, artificial pandemics, runaway artificial intelligence. The same intelligence that allows a species to master science may also create tools capable of ending its future. And if countless civilizations throughout cosmic history reached this dangerous stage and failed, then the silence of the universe might not be mysterious at all. It may simply be the sound of civilizations that never made it. That possibility forces humanity to confront an uncomfortable truth. The Fermi paradox is not only about aliens, it may also be about us. It asks whether intelligent life naturally survives long-term or whether self-destruction is the normal fate of technological civilizations. And honestly, we don't know. There are other explanations too. Maybe advanced civilizations deliberately remain silent. Maybe they observe young civilizations like ours without interfering. Maybe interstellar travel is far more difficult than we imagine, or perhaps alien communication methods completely beyond our understanding. Humanity searches mostly for radio signals because radio is the technology we understand. But a civilization millions of years ahead of us may communicate using physics we haven't discovered yet. Trying to detect them with current technology may be like a caveman attempting to intercept the internet using a stone tool. The limitation may not be the universe. The limitation may be us. And perhaps the strangest realization of all is this: the universe has not yet answered Fermi's question, where is everybody? We still don't know. But every year our instruments improve, our telescopes become more powerful, our understanding grows deeper. And somewhere between the silence and the stars, humanity continues searching for an answer. Because if we eventually solve the Fermi paradox, it may completely transform our understanding of life, intelligence, and our place in the cosmos. In 1961, an astronomer named Frank Drake attempted something remarkable. Instead of treating the question emotionally or philosophically, he tried turning it into mathematics. Not because he believed mathematics could magically provide the final answer, but because science works best when it transforms vague mysteries into measurable problems. That idea became known as the Drake equation. At first glance, the equation looks intimidating. People hear the words equation and immediately imagine complicated physics scribbled across a chalkboard. But the logic behind it is surprisingly simple. The Drake equation is essentially a series of questions multiplied together. Questions about stars, questions about planets, questions about biology, questions about intelligence, questions about civilization itself. It begins with something we now understand fairly well: the rate at which stars form in our galaxy. The Milky Way constantly creates new stars. Some estimates suggest several new stars are born every year. That alone matters because Y star represents a possible solar system, a possible world, a possible environment where life might emerge. Then comes the next question: how many of those stars have planets orbiting them? When Frank Drake first proposed his equation, we didn't know the answer. Planetary systems beyond our own were still theoretical. Today we know planets are everywhere. Thanks to modern telescopes and missions like Kepler, astronomers have confirmed thousands of exoplanets, and evidence strongly suggests most stars possess planetary systems. That realization dramatically changed scientific thinking. Planets are not rare accidents. They appear to be a natural consequence of star formation. Then the equation asks another question: how many of those planets could support life? Not every planet is suitable. Some are frozen worlds with temperatures colder than Antarctica. Others are scorching infernos hot enough to melt metal. Some may be gas giants without solid surfaces, but among the county NT-least planets scattered across the galaxy. Some exist inside habitable zones where liquid water could potentially survive. And wherever liquid water exists, scientists become interested, because on Earth, water is tied to every known form of life. The equation then moves into deeper uncertainty. How often does life actually begin? This is where science becomes humbling. We still do not fully understand how life first emerged on Earth. At some point billions of years ago, non-living chemistry crossed a mysterious threshold and became biology. Simple molecules somehow organized into self-replicating systems. That transition remains one of the greatest unsolved mysteries in science. And because we only have one confirmed example of life, Earth, we don't know whether life is common or unbelievably rare. Maybe life appears easily wherever conditions are right. Or maybe Earth experienced an event so improbable that it happened only once in the observable universe. Right now, I simply don't know. Then comes another critical question. Even if life begins, how often does intelligence evolve? This part is especially fascinating. Life appeared on Earth relatively quickly after the planet cooled enough to support oceans. But intelligent life took much longer. For most of Earth's history, the planet was dominated by simple single-celled organisms. Bacteria ruled this world for billions of years. Complex multicellular life emerged much later. And technologically advanced intelligence, that happened only very recently. Human civilization occupies a microscopic instant in cosmic time. This suggests something important. Life and intelligence may not be the same thing. The universe could be full of microbial life, while intelligent civilizations remain extraordinarily rare. Perhaps evolution rarely produces creatures capable of science, mathematics, and technology. And even if intelligent civilizations emerge, another question remains. How long do they survive? This may be the most unsettling part of the Drake equation, because technological intelligence creates immense power. Civilizations capable of space communication are also capable of nuclear weapons, environmental destruction, artificial pandemics, and technologies powerful enough to threaten their own survival. Humanity itself now possesses the ability to damage the entire planet. That raises a disturbing possibility. Maybe most civilizations destroy themselves shortly after becoming technologically advanced. Maybe the lifespan of intelligent societies is tragically short. And if that's true, then even a galaxy filled with civilizations could appear silent because the overlap between them is tiny. One civilization may rise and disappear millions of years before another even evolves. The cosmos may be filled with ancient ruins and forgotten histories separated by enormous stretches of time. This is why the Drake equation matters so much. Not because it gives us certification. It doesn't. In fact, many of the numbers inside the equation remain deeply uncertain. But that uncertainty is valuable because the equation transforms a mysterious philosophical question into a scientific roadmap. It shows us exactly what humanity still needs to learn. How common are habitable planets? How does life begin? How often does intelligence evolve? How long can civilizations survive? Every new telescope, every Mars mission, every exoplanet discovery, every advancement in biology helps humanity slowly fill in those blanks. And perhaps the most beautiful part of all is this. For the first time in human history, we are no longer limited to simply wondering whether we are alone. We are finally learning how to investigate the question scientifically. And that may become one of the most important scientific journeys our species ever undertakes. An ocean is big. A planet feels big when you stand on it. But the universe is something else entirely. The scale of it doesn't merely surprise the human mind, it overwhelms it. The moment you genuinely try to visualize the cosmos, your intuition begins to break down. Human beings evolved to understand forests, rivers, storms, distances we could walk across. We did not evolve to emotionally process billions of galaxies separated by unimaginable stretches of space and time, and yet the numbers are real. Our galaxy, the Milky Way, contains somewhere between 200 and 400 billion stars. Think about that carefully. Every single point of light you see in the night sky is a star. Many of them are larger, brighter, and older than our sun. Some have existed for billions of years before Earth even formed. And our sun itself, it's completely ordinary, not the biggest, not the brightest, not the rarest. Just an average middle-aged star sitting quietly in one spiral arm of the Milky Way galaxy. Now here's the part that truly changes perspective. The Milky Way is not the universe. It's only one galaxy. Among an estimated 2 trillion galaxies in the observable universe. 2 trillion. That number is so enormous the human brain almost refuses to accept it. If you tried counting one galaxy every second, it would take tens of thousands of years just to count them all. Inside those galaxies are stars beyond comprehension. Astronomers estimate there are roughly 10 to the 24th stars in the observable universe. That's a 1 followed by 24 zeros. More stars than all the grains of sand on every beach and every desert on Earth combined. And for most of human history, we didn't even know whether those stars had planets orbiting them. We could only speculate. Today we know they do. Since the 1990s, scientists have discovered thousands of exoplanets, planets orbiting stars beyond our solar system. And what shocked astronomers wasn't merely that planets existed elsewhere, it was how common they are. Planetary systems appear to be normal. Some stars host giant gas worlds larger than Jupiter, Jupiter. Others have rocky Earth-like planets. Some systems contain multiple worlds orbiting in complex patterns. And increasingly, we are finding planets located inside what scientists call the habitable zone, the region around a star where temperatures may allow liquid water to exist. Liquid water matters because, as far as we currently understand, water is essential for life. Every living organism on Earth depends on it. So now let's step back and think carefully about what all this means. If there are trillions of galaxies and billions of stars inside each galaxy and planets orbiting many of those stars, then the number of potentially habitable worlds becomes staggering. Not one, not hundreds, not thousands, potentially billions upon billions. And suddenly the question changes. The idea of life elsewhere no longer feels absurd. In fact, what begins to feel strange is the assumption that life happened only once, only here, on one tiny planet orbiting one ordinary star. Now, that doesn't prove alien civilizations exist. Science doesn't allow us to leap from possibility to certainty, but the scale of the universe forces us to take the question seriously. because probability matters. If life emerged naturally on Earth, if chemistry and physics, under the right conditions, can eventually produce biology, then it becomes difficult to imagine Earth as the only place where it ever happened. After all, the atoms inside your body are not unique to Earth. Carbon exists throughout the cosmos. Hydrogen is everywhere. Oxygen, nitrogen, phosphorus, the chemical ingredients of life, are some of the most common elements in the universe. The universe is not lacking raw material. In many ways, the cosmos appears chemically prepared for life. And perhaps the most astonishing realization of all is this: everything we have ever known, every human being who ever lived, every empire, war, religion, scientific discovery, love story, and dream, all of it happens, net on a tiny world suspended in an ocean of cosmic darkness. When you truly absorb that perspective, something shifts inside you. The petty divisions between nations begin to feel smaller. Human history begins to feel fragile, and the night sky transforms from decoration into possibility. Because somewhere among those countless stars, there may be worlds with oceans, atmospheres, storms, continents, maybe even civilizations asking the same question we are asking right now. Are we alone? And the honest answer is yes, we still don't know. But for the first time in history, humanity finally possesses the tools to begin searching for the answer. There's another possibility we have to consider. Maybe alien civilizations exist and we simply aren't detecting them. Not because they're hiding, not because they're avoiding us, but because our methods of searching may still be primitive. Humanity has only been seriously listening for extraterrestrial signals since the 1960s. That means we've spent roughly 60 years scanning the skies in a universe that is nearly 13.8 billion years old. Cosmically speaking, that's less than a blink. Imagine standing on the shore of the ocean, dipping a single glass into the water for 1 second, finding no fish, and concluding the entire ocean is empty. That would obviously be absurd. And yet, in many ways, that's roughly the scale of humanity's search so far. We've explored only a tiny fraction of our own solar system in detail. We've examined only a small number of exoplanet atmospheres. We've listened to only a microscopic region of the galaxy for radio transmissions. The search has barely begun. And even more importantly, we may be searching in entirely the wrong way. Most SETI programs, the search for extraterrestrial intelligence, focus heavily on radio waves. Why? Because radio communication is a technology humanity understands well. Radio signals can travel enormous distances through space. They're really tightly cheap to produce and relatively easy to detect. For decades, scientists assumed advanced civilizations might also use radio communication, making it a logical place to start. But think carefully about how limited that assumption might be. Human beings have used radio technology for only about 100 years, just 1 century. Technology evolves rapidly. 100 years ago, television didn't exist. The internet didn't exist. Satellites didn't exist. Smartphones didn't exist. Now imagine a civilization that is not 1 century ahead of us, but 1 million years ahead. Their technology might be completely incomprehensible to us. They may communicate using methods based on physics we haven't discovered yet. Quantum communication, neutrino signaling, artificial manipulation of space-time, concepts entirely outside current human understanding. Trying to detect such a civilization using radio telescopes might be like a medieval peasant trying to intercept Wi-Fi signals with a wooden spoon. The signals could be everywhere, and we would never even recognize them. This realization is deeply humbling. Humanity tends to assume our current understanding of science represents reality itself. But history repeatedly teaches us otherwise. There was a time when humans believed Earth was the center of the universe. There was a time when electricity seemed magical. There was a time when invisible germs causing disease sounded absurd. Again and again, nature has revealed layers of reality beyond human intuition. So we should remain cautious about assuming our current technology defines the limits of possibility. And there's another important factor most people forget. Distance. The galaxy is unimaginably large. The Milky Way alone stretches roughly 100,000 light years across. That means if a civilization on the opposite side of the galaxy sent us a radio signal today, it would not arrive for 50,000 years. And if we replied immediately, our response, would take another 50,000 years to reach them. Conversations across the galaxy may unfold over timescales longer than human civilization itself. Now consider humanity's own broadcasts. We've only been sending detectable radio signals into space for about a century. That means our radio bubble extends roughly 100 light years in every direction. 100 light years sounds enormous, but relative to the size of the Milky Way, it's tiny. Most of the galaxy has absolutely no idea humanity exists yet. We are essentially cosmic infants who just learned how to shout into the dark. Another possibility is even stranger. Maybe advanced civilizations intentionally remain quiet. Some scientists speculate that broadcasting your location into the cosmos may not be wise. If dangerous civilizations exist somewhere out there, silence could become a survival strategy. This idea is sometimes called the dark forest theory. The concept is unsettling. Every civilization stays silent because nobody knows who else may be listening. The galaxy becomes a dark forest filled with hidden hunters, where revealing your location could be fatal. Now, whether that theory is true is impossible to know, but it highlights something important. We often assume alien civilizations would think like humans. That may be a mistake. Alien intelligence could possess completely different motivations, psychologies, or priorities. They may have no interest in exploration, no interest in communication, no interest in contacting primitive civilizations like ours, or perhaps they communicate in ways we mistake for natural phenomena. After all, sufficiently advanced technology might appear indistinguishable from nature itself. A civilization millions of years ahead of humanity could manipulate stars, engineer